All right, today we're going to dive deep into architecting your compute in Azure Kubernetes Service. And look, the goal here is to get past just running apps. We're talking about mastering the tools that let you build systems that are powerful, super resilient, and, this is the big one, actually cost-effective. So, let's get into it.
So, this is the fundamental puzzle, right? Every cloud architect bumps into this. You've got your critical APIs, you've got some heavy machine learning tasks, maybe even a few old-school legacy apps, and they all have to live together. How do you manage this whole zoo inside one single AKS cluster without it becoming a total mess? Well, that's the puzzle we're going to solve today.
So here's our game plan. We'll start with the why, the absolute core principle of separating your workloads. Then we'll get our hands dirty with the essential AKS tools. We're going to make our cluster smart with auto-scaling, unlock some serious cost savings with what I call the spot node gambit, and then we'll wrap it all up with 3 production-ready best practices you can literally start using tomorrow.
Okay, first things first. Before we touch a single tool, we have to get our heads around the core strategy here, and that is workload separation. This isn't just some nice-to-have feature, it's the absolute bedrock of a healthy, efficient Kubernetes cluster. Think of it this way. You do not want some random data processing job to suddenly go wild, eat up all the memory and CPU, and take down your customer-facing API. That's a nightmare. By creating these digital walls between them, you prevent that noisy neighbor problem. This guarantees stability for your critical stuff and lets other jobs get the specialized hardware they need to run their best.
So how do we actually build these walls? Well, AKS gives us a really simple but incredibly powerful toolkit. Let's break down the core building blocks we're going to be playing with.
The main tool in our belt is the node pool. Honestly, the best way to think about a node pool is like a specialized department in your compute factory. Each department is filled with identical machines, all perfectly configured for one specific type of job. And the best part? You can have as many of these specialized departments as you need. And this table right here shows you exactly why you do this. Check out that first row. For pure isolation, you create a dedicated system pool. This is just for Kubernetes' own critical services. Seriously, this is not negotiable for a stable cluster. Then you see in the second row, if you're doing AI stuff, you'll need a pool with those beefy GPU-enabled VMs. And for those classic .NET apps, last row shows you can even have a node pool running Windows Server. It's all about picking the right tool for the right job.
But just creating the pool is only half the battle. Inside each one, you have to pick the right virtual machine size. This is where your strategy really hits the budget. You wouldn't use a freight train to deliver a pizza, right? Same idea. It's this constant critical balancing act between getting the raw power you need and keeping that cloud bill from giving you a heart attack.
Now, having these fixed-size node pools is a great start. But what happens when traffic goes crazy at 2 a.m.? We need our cluster to react. And that's where we get really smart with auto-scaling.
AKS has this amazing built-in feature called the Cluster Autoscaler. Its job is super simple. It just watches the cluster and acts like a resource manager, making sure you have exactly the number of machines you need at any given moment, no more and no less. The logic behind it is just brilliantly simple. If a new pod needs to run, but there's no room at the inn, the autoscaler sees that, and boom, it adds a new node to the pool. On the flip side, if it notices some nodes are just sitting around twiddling their thumbs, it will safely drain the work off them and shut them down to save you cash. It's a two-way street. It scales up for performance, and it scales down for cost. It's beautiful. Okay, now for the advanced move. This is the one that can slash your costs like crazy, if you play your cards right. Let's talk about the spot node gambit.
So, spot node pools are this special kind of node pool that basically runs on Azure's spare computing power. And because you're using leftovers, you get them at a crazy discount. We're talking up to 90% off sometimes. But, and this is a huge but, there's a catch. Azure can take that compute capacity back whenever they want with very little warning.
This slide really lays out the trade-off perfectly. Your standard nodes, they give you guaranteed availability. You pay a predictable, higher price, which makes them perfect for your absolutely critical, cannot-fail applications. Spot nodes, on the other hand, offer zero guarantees but come at that massive discount. This makes them absolutely ideal for workloads that are built to be interrupted and can just pick up right where they left off.
So let's tie all of this together with a real-world scenario you've probably seen a dozen times. Imagine you're running a web app, and that app kicks off background jobs, things like processing images somebody uploaded or generating a PDF report.
These two workloads have totally different personalities.
The API, it has to be up 24/7. It has to be responsive, it has to be stable. Cost is important, but stability is king. The background jobs, though, they can be stopped and started again. They aren't super time sensitive, and frankly, you want to run them for as cheap as humanly possible. And here is the elegant solution. We create two node pools. The first one, let's call it User Pool API, runs on those reliable standard VMs for our critical APIs. The second one, Spot Pool Batch, runs on those super cheap Spot VMs for all our interruptible jobs. And notice, we enable auto-scaling on both of them, so we're only ever paying for exactly what we use. This, right here, is a perfect separation of concerns.
But we absolutely have to talk about that catch. There's a saying that goes around, eviction is not a bug, it's a feature of Spot nodes. You have to embrace this. You have to design for it from day one.
So what is eviction? It just means Azure needs that compute power back for a full-price customer. And with as little as 30 seconds of warning, they will pull the plug on your Spot node. Any pods running on it get terminated. This is exactly why you can never, ever run a database or any other critical service on a Spot node pool. It's just not what they're for.
Okay, let's wrap this all up. We're going to distill everything we've talked about into 3 essential, production-ready best practices for any AKS cluster you run. Number 1, always, and I mean always, create a dedicated system node pool. This isolates Kubernetes' own brain for way better stability. Number 2, use taints and tolerations. Think of it like a bouncer at a club. A taint on a node repels all pods, and a toleration on a pod is like a VIP pass that lets it in. This is how you make sure only your AI jobs run on those expensive GPU nodes. And finally, number 3, if you're going to use Spot nodes, your application code must be built to be fault tolerant. It has to know how to handle being interrupted gracefully.
And that brings us to our final thought. Now that you have this toolkit, I want you to take a hard look at your own applications. What batch job, what data analysis task, what testing environment do you have running right now that you could move to a Spot node pool tomorrow and instantly start saving money? Seriously, the savings are just sitting there, waiting for you.